Hey kids, welcome to section 3.5, solving quadratic equations by completing the square. Today I'm going to teach you how to solve quadratic equations by using the square root property and how to solve quadratic equations by completing the square. So first thing, let's talk about something called the square root property. The square root property allows you to take the square root of both sides in order to solve an equation. So think about way back in the beginning, if you had something like x squared equals 4, you could solve this equation for x by square rooting both sides. And when you square root 4, you get not only 2, but you also get negative 2 because 2 times 2 is 4 and negative 2 times negative 2 is 4. The reason why you can square root both sides is because of the square root property. So let's see how we can use that to solve quadratics. If we look at letter A, solve each equation by using the square root property. Notice that the left side can be factored. I can find two numbers that add to give me negative 12 and multiply to give me 36. So if I set up my two parentheses, I can put x and x. I can find the two numbers to be 6 and 6, and they're both negative. So watch, I can rewrite this as x minus 6 quantity squared equals 25. Now I have two sides of an equation that are both perfect squares. I can solve by square rooting both sides. So x minus 6 equals plus or minus 5. Then I can solve for x by adding 6 to both sides. So x equals 6 plus or minus 5. Usually you're not going to see plus or minus 5 and then plus 6. Usually the plus or minus part comes second. That's why I snuck the 6 in front. Now this gives me my two answers. One of my answers is 6 plus 5, which is 11. And my other answer is 6 minus 5, which is 1. So both of these numbers, if I plug them in for x, should give me 25. Also, remember that the whole point of solving a quadratic is to figure out where the graph crosses the x-axis. So if I were to graph the equation in letter A, I would see that the parabola crosses the x-axis at 1 and 11. All right, so now if we take a look at B, we can factor the left side here. We can say x minus and x minus, and the two numbers that add to give me negative 16 but multiply to give me 64 are 8 and 8. So I can write that as x minus 8 quantity squared equals 49. Then to get inside of the parentheses, I can undo the square by square rooting both sides. So that gives me x minus 8 equals, and the square root of 49 is not only 7, but also negative 7. Then to solve for x, I can add 8 to both sides. So x equals, put the 8 in front, plus or minus 7. Then I can find what x is by doing 8 plus 7, which is 15, and 8 minus 7, which is 1. So again, that's the place where the parabola from the original problem crosses the x-axis. All right, so we're going to use that square root property and something called completing the square together in order to solve some equations. So the whole point of completing the square is to take something that is not a perfect square trinomial and make it a perfect square trinomial so that we can do the just what we did on the previous slide. Now there are 3 steps to completing the square. The first step is to take the b, which is the term in front of, or is the value in front of the x, and divide it by 2. Then you square whatever answer you get, and then you add it to both sides of the equation. Obviously, that doesn't make much sense until we actually do an example. So if we look at letter A, solve each equation by completing the square. What you're going to do is first, you're going to get all the letters on the left side and anything that's not a letter on the right. So I'm going to go x squared minus 10x, subtract the 24 over, equals negative 24. So that's step one, is to make one side be just letters and the other side numbers. Then I'm going to do x squared minus 10x plus and leave a little line equals negative 24 plus and leave a little line. So the reason why I put these plus lines here is because that's where I'm going to put my completing the square value that we just talked about getting. See, x squared minus 10x plus 24 is not a perfect square trinomial. I can't find a number that multiplies by itself to get 24 and adds to get negative 10. It's not possible. So we're going to make there be a perfect square trinomial on the left side of the equation. So we're going to take the middle term, the b value, which is negative 10. I'm going to find 1/2 of b. So I'm going to divide by 2. Then step 2 says to square the result. So I'm going to square. And then that value gets added to both sides. So negative 10 divided by 2 is negative 5. Negative 5 quantity squared is 25. So I'm going to put a plus 25 on both sides. Now on the left side, I can take the long way, which is to find the two numbers that multiply to give me negative 10 and add multiply to give me 25, add to give me negative 10, or I can take the shortcut, which is kind of right here. And so what you do is you take the letter from the problem and you put it in the parenthesis. You take the sign that's after that and you put it in the parenthesis. And then you take the half number, b divided by 2. So that's negative 10 divided by 2. That's negative 5, so that goes there. Quantity squared equals, and then negative 24 plus 25 is 1. So we have taken an equation that is not a perfect square trinomial, and we have made it into an equation with a perfect square trinomial. Now I need to get inside to get to the x, so I'm going to square root both sides. So that gives me x minus 5 equals plus or minus 1. I'm going to add 5 to both sides. So x equals 5 plus or minus 1. So that gives me 5 plus 1, which is 6, and 5 minus 1, which is 4. So if I were to graph that original quadratic on the coordinate plane, I would see that it crosses the x-axis at 4 and at 6. And actually, here's another way. You can solve this equation without completing the square. You could find two numbers that add to give you negative 10 and multiply to give you 24. That would be x and negative 6 and negative 4. And so x equals 6 and x equals 4. Obviously, it's a lot easier and quicker to do it by factoring. However, the directions want us to practice completing the square. We get the same answers. All right, so first thing we're going to do in letter B is we're going to make all the letters be on the left side, numbers on the right. So x squared plus 8x equals, and subtract 16 over, gives you negative 15. Then we can complete the square. So we're going to do plus a little line, negative 15 plus a little line. Remember, they're both plus because no matter what value I have, when I square it, it's going to be a plus 25 in order for it to be a perfect square trinomial. So it's always going to be added to both sides. Okay, so my middle term is 8. So if I take 8, find half of it, then square it. That's what goes on the line. So 8 divided by 2 is 4. 4 squared is 16. So I'm going to put a 16 here and a 16 here. So I'm going to get x. Take the letter, put it here. Take the sign, put it here. Take half of 8, put it here. Equals 1. So you may have noticed I could have gone exactly from x squared plus 8x plus 16 right down here to factoring, but now you know completing the square works. All right, go ahead and square both sides in order to get rid of the square. So I got x plus 4 equals plus or minus 1. Subtract 4. So x equals negative 4 plus or minus 1. Well, negative 4 plus 1 is negative 3, and negative 4 minus 1 is negative 5. All right, so that's how you solve an equation by completing the square. Let's see what happens when the value in front of x squared, the a value, is not 1. So both of the equations on the previous slide had 1x squared and continuing on. However, these do not. So the first thing you need to do is the same thing you did before. Get the letters on the left, numbers on the right. So 3x squared plus 10x equals 8. Then I need to divide the entire equation by 3 because I need the value in front of the x squared to be 1 in order to complete the square. So dividing by 3 gives me x squared plus 10 thirds x equals 8 thirds. All right, now we're going to complete the square. So x squared plus 10 thirds x plus something equals 8 thirds plus something. Well, to find that something, I take the b value, which is 10 thirds, divide it by 2, and square. Okay, well, if you have a calculator, you could type this all into your calculator, easy peasy. If you don't, then you should remember that when you divide by something, you really multiply by the reciprocal. So that gives us 10 over 6, which is 5 thirds. Then I got to square it. So that's 25 ninths. That's what gets added to both sides. Now, if you don't like that, then use your calculator and you can get the same thing. Okay, on the left side, we're going to factor it. So the letter from the problem is the letter in the parentheses. The sign in the problem is the sign in the parentheses. And remember, this value that goes in the parentheses is the b divided by 2 number, which was the 5 thirds. So I can put 5 thirds here. And then on the other side, if I find a common denominator, that would be 9. So this would be 49 ninths. Again, if you don't like fractions, all you got to do is grab your calculator and type it in. So now I can square root both sides. So I get x plus 5 thirds equals plus or minus. Now to square root a fraction, you share the square root. So it's really square root 49 over square root 9. So the square root of 49 is 7, and the square root of 9 is 3. Then I minus 5 thirds. So that gives me negative 5 thirds plus or minus 7 thirds. Well, if I do negative 5 thirds plus 7 thirds, that gives me 2 thirds. If I do negative 5 thirds minus 7 thirds, that gives me negative 12 thirds, which is negative 4. So x is 2 thirds and negative 4. Again, if we were to graph the original quadratic, it would cross the x-axis at 2 thirds and negative 4. All right, let's take a look at B. First thing, letters on the left, numbers on the right. So 3x squared plus 14x equals 16. Can't have a coefficient in front of the x squared, so divide everything by 3. X squared plus 14 thirds x equals 16 thirds. Set up for completing the square. X squared plus 14 thirds x plus something equals 16 thirds plus something. So to find that something, we take our b value, which is 14 thirds, and divide it by 2. If you don't like fractions, use your calculator, but it's 14 thirds times the reciprocal 1/2. which is 14 over 6, which is 7/3. So we're going to add, then we have to square it. So that gives me 49 ninths. Oh, that's weird. 49 ninths again. So 49 ninths and 49 ninths. Okay, so when we factor it, we take the letter from the problem, put it in the parentheses, take the sign from the problem, put it in the parentheses, take the half number, which was 7/3, equals, and then we need to add these two fractions together. If you don't know how to do it, grab your calculator. We're going to multiply by 3 to get 9, so that's 48, and 49 is 97 ninths. Then to get to the x, we're going to square root both sides. So x plus 7/3 equals plus or minus, and I'm going to split this apart, square root 97 over square root 9. I split it apart because you can take the square root of 9. So that gives you x plus 7/3 equals plus or minus. Now I can't do the square root of 97, so I'm going to leave it root 97. But I can do the square root of 9, it's 3. So notice that my 3 on the bottom is not underneath the radical anymore. Okay, minus 7/3 minus 7/3. So that gives me x equals negative 7/3 plus or minus root 97/3. Well, since they both have a denominator of 3, I can put them together and say negative 7 plus or minus square root 97 over 3. It's not a very nice number. It's a decimal. I could figure out what it is if I wanted to put it in my calculator, but we're going to leave our answer as an exact answer, not a decimal. All right, so that's what to do when the value of A is not equal to 1. Let's look what to do when we get imaginary solutions. Okay, so first thing, letters on the left, numbers on the right. So x squared plus 2x equals negative 2. Then we want to complete the square. So x squared plus 2x plus something equals negative 2 plus something. To find the something, I'm going to take the b, which is 2, divide it by 2, and square it. So 2 divided by 2 is 1. 1 squared is 1, so I'm going to add 1 to both sides. I factor the left side. Letter from the problem is the letter in the parentheses. Sign is the sign. And the half term goes in the parentheses, which 2 divided by 2 was 1. And on the right side, I get negative 1. Then I can square root both sides. So I get x plus 1 equals plus or minus the square root of negative 1. Now remember that when you have the square root of negative 1, that's another way of saying I. So x plus 1 equals plus or minus I, because remember the square root of negative 1 is equal to I. Then I can minus 1 to both sides, x equals, and we want to write this as a complex number, which is negative 1 plus or minus I. So this means that my parabola is going to open upwards and it's never going to cross the x-axis, which is why the zeros are imaginary. Okay, if we look at letter B, first thing, move the 25 over. So x squared minus 6x equals negative 25. Then I can complete the square. So x squared minus 6x plus something equals negative 25 plus something. Take your middle term, which is negative 6, divide it by 2 and square it. So negative 6 divided by 2 is negative 3, squared is 9. Factor, so we get x. This time the symbol is a subtraction, so it's minus, and the half term is 3 equals, and when I add negative 25 and 9, negative 25 and 9 together, I get negative 16. Square root, square root, So x minus 3 is equal to plus or minus the square root of negative 16. Now we learned how to simplify square root of negative 16. Remember, that's the square root of negative 1 times the square root of 16. Square root of negative 1 is I, and the square root of 16 is 4. So that's 4i. So we get x minus 3 is equal to plus or minus 4i. Then I can add 3 to both sides. X equals 3 plus or minus 4i. Always write it with the real part first, then the imaginary part. All right. Here's a use of completing the square. It's something called vertex form. Now, vertex form has a vertex form is another way that you can graph a quadratic equation. So if you're given a parabola and told to graph it, you can do the old negative b over 2a method that we learned about in section 3.1, or you can do this new method, which is called vertex form. Vertex form usually looks like f of x equals, you have an x and like a minus or a plus inside. So we'll say, I don't know, plus b over 2, it's squared. And then you have a plus or a minus number over here, and then some kind of number. And then you can use this to graph your quadratic. So when you complete the square to write the function in vertex form, that's what we're doing, you're going to do y equals, you're going to start a parenthesis, you're going to keep the letters together, so x squared plus 4x, and then you're going to complete the square, then you're going to have your plus 6, and then you're going to have minus, and you're completing the square. So let me do some explaining. So first of all, notice that the equation is not equal to 0. When it was equal to 0 on the previous slides, we were able to solve for x to figure out where it crosses the x-axis. Well, we don't have an equals 0 here. We have an equals y here. That's the reason why we're keeping everything on the right side together. Now, the reason why one of the lines is a plus and one of the lines is a minus is because normally we're putting a plus completing the square thing on both sides to even out the equation. But this time they're both staying on the same side. So in order for whatever we add here to balance out to 0, I have to subtract it over here. So if we complete the square, we're still going to take half of the middle term and square it, and that's what goes on the line. It's just one of them is positive and one of them is negative. So here we have 4 divided by 2, which is 2, and 2 squared is 4. So I'm going to put a 4 on both of the lines. Then we factor this like we did on the previous slide. Letter in the problem, letter in the parentheses, sign in the problem, sign in the parentheses. Half number goes next, 2. And then notice that 6 minus 4 is 2. This is vertex form. It's y equals, it's a quantity squared plus a number. So we had y equals a quantity squared plus a number. So this is vertex form. And what's really nice about this is think about the translations that we learned about in the previous chapter. This plus 2 on the inside means to go left 2. And this plus 2 on the outside means to go up 2. That's why our vertex is negative 2, 2, left 2, and up 2. A vertex is just a translation. It tells you which way you've moved and in which direction how much. So you don't have to write the translation part here. I just wanted you to see that that kind of leads to where the vertex is. All right, let's do another one. This time there is a 2 in front. So we are going to do y equals. Now, when you separate your letters from your numbers, you also at the same time have to factor out whatever number is in front of the x squared. So I'm going to write 2 times x squared minus 6x, and then that 17 is still hanging out. So again, I just factored out a GCF of 2 and got that. Now I'm going to complete the square. So x squared minus 6x plus something plus 17 minus something. So I'm still going to take half and square it. So half of negative 6 squared is 9. But here's where it gets a little tricky. This 9 is not just 9, but it's actually 2 times 9, because this 2 is hanging out inside of the parentheses. And so I need to balance it out. 2 times 9 is 18, so that's why I put in 18 here. So make yourself a little note that this is really 2 times 9. Because remember, I want to be able to simplify that last line down and get the original problem. And I do if I do 2 times 9 is 18. Now I got y equals 2. I can factor x minus 3. And I have a minus 1. Well, that's in factored form, or vertex form. That 2, by the way, means it's a vertical stretch by a factor of 2. And my vertex, well, what does that minus 3 mean? That means to go right 3, so my vertex is 3. And the negative 1 means to go down 1, which is why my vertex is negative 1. So remember, this in here means right 3. This means down 1. And then that 2, by the way, is a vertical stretch. Put it all together. All right, that's the end of lesson 3.5. If you guys have any questions, please let me know. And as always, keep calm and keep trucking.